Welcome students. Today we are going to discuss about the procedure and demo of the colorimetric experiment. For this, first of all, in the procedure part, we have to prepare 6 test tubes. First test tube preparation. First test tube is your reference test tube. In this, we don't have to add iron 3 solution, but we have to add concentrated HNO3 1 ml solution, KCNS 0.5 ml solution, and rest we have to make up with distilled water, which is 8.5 ml solution. Now, in the same way, we have come to prepare second test tube. In the second test tube, we have to add 0.5 ml iron 3 solution, 1 ml HNO3 and 0.5 ml KCNS, and the rest 8.0 ml distilled water. In the third test tube, we have to add 1 ml iron 3 solution, 1 ml HNO3 solution and 0.5 ml KCNS and 7.5 ml distilled water. In the same way, fourth test tube, we have to add increase the concentration of iron sample. In this, we have to add 1.5 ml iron sample, 1 ml HNO3, 0.5 ml KCNS and rest distilled water, which is 7.0 ml. In the same way, we have to prepare fifth test tube, 2 ml of iron third solution, 1 ml HNO3, 0.5 ml KCNS and 6.5 ml distilled water. For this experiment, we need the conversion factor, because we have taken the reading from the burette in ml. We have to convert in milligrams per liter, where 1 ml is equal to 0.05 milligrams per liter. In the observation table, you have to feed the value in the manner. Solution 1, 2, 3, 4, 5, 6 and the last one is for the unknown. Concentration you have to report in milligrams per liter. For this you have to convert 1 ml is equals to 0.05 milligrams per liter. In the same way, in the first test tube there is a no iron 3 solution, so 0 multiplied by 0.05, it is equal to 0. In the second test tube we have to take the iron concentration 0.5 ml, which is multiplied by 0.05. In the same way, in the 3, 4, 5, 6 test tube, we have to calculate the concentration in milligrams per liter, and we have to report the absorbance in this column. For the first test tube, absorbance is 0 because there is a no color. If the solution is colorless, then no absorbance is reported. 6 test tube for the experiment. For the first test tube, as we have given in the instruction that there is no need to add iron 3, we have to add only 0.5 ml KCNS, 1 ml HNO3, and with the help of measuring cylinder, we have to add 8.5 ml distilled water. So this is the first test tube. In the second test tube, we have to add 0.5 ml iron third, 0.5 ml KCNS. Now, KCNS is a color developing agent, that's why the solution becomes colored. Now, we have to add 1 ml HNO3 and rest 8 ml distilled water. In the same way, you have to prepare 6 test tubes. In the first test tube, you have seen there is no iron sample, that's why it is a colorless. In the second test tube, 0.5 ml. Third test tube, 1 ml. Fourth test tube, 1.5 ml. Fifth test tube, 2 ml. And the last test tube, 6th test tube, 2.5 ml. As you have seen, as you increase the concentration of iron, the color intensity of the complex also increases. we are going to find out the absorbance of the all 6 test tube with the help of colorimeter. This is the colorimeter. In this, first of all, we have to select the filter. Filter is selected on the basis of the color. As in the given test tube, the color is red. So, we have to select the complementary color. First of all, we have to calibrate the colorimeter with the help of this test tube, because in this test tube there is no color because there is no iron sample. We have to fill, this is the cuvette. We have to fill this up to 3/4 mark. Now, you have to dry this cuvette with the help of filter paper. Otherwise, the moisture present in the filter paper will destroy the instrument and your reading will also vary. Now, insert this cuvette in the colorimeter. Now, we have to calibrate because there is no color, so it means the absorbance should be 0. Now, the instrument is calibrated. So, for the first concentration 0, the absorbance value comes 0. Now, take second test tube in which there is iron concentration is 0.5 ml. In the same way, fill. Now, dry with filter paper and insert in the colorimeter. Now, the reading reported is 0.06. Take out the cuvette and insert the solution in the conical flask. Now, take the third test tube. Fill the cuvette 3/4. Dry with filter paper. Insert in the colorimeter. Now, reading reported is 0.13. Now, take out the cuvette and fill the solution in the conical flask. Now, take the fourth test tube. Fill the cuvette again 3/4. Dry with filter paper and insert in the colorimeter. Now, reading reported is 0.20. Now, take out the cuvette and drain the solution in conical flask. Now, take the fifth test tube. Fill the cuvette 3/4. Dry with filter paper and insert. So, in this conical flask, we don't know what is the concentration. And our main objective is to find out the unknown concentration of iron. For this, we have to again fill this cuvette 3/4. Dry with filter paper. Insert in the colorimeter and we have to record this reading. With the help of this reading, we have to calculate the unknown concentration with this known absorbance value. As you have seen, as the concentration increases, the absorbance value increases. Now we have to plot the graph between the absorbance and concentration. We put the value of absorbance in y-axis and concentration is on x-axis. All the points lie on the same line and from the origin. The graph between absorbance and concentration is known as calibration graph. With the help of unknown absorbance value, we have to calculate the unknown concentration from calibration we have to calculate the unknown concentration with the help of absorbance value of unknown solution. The point where that absorbance value intersect this line, from that point we have to draw the perpendicular on concentration, which is on x-axis. From that we have to calculate the unknown concentration with the help of scale. Thank you.